Hey guys, welcome back to CMTEQ channel. This is tutorial 2 on our series of current transformer calculations or instrument transformers. As you can see right here on our screen, we have this black one here. We have this one here is a high voltage transformer. Those ones are normally found on substation, distribution substation or transmission substations for measurement purposes, okay? And this small one here can also be for high voltage depending on the size, but these are mostly for low voltage, usually found in electronics equipment. Please watch the first tutorial where I talk more details about these two types of current transformer. There are many more types, but I'm just representing these two right here. Now, before we continue, please don't forget to subscribe to CMTEQ channel and give this tutorial a thumbs up. That will be highly appreciated. Okay, so what we have here, they say we need to calculate the CT VA rating that will supply a relay of 10 VA through a loop resistance of 2 ohm. Now we need to use 1 amp secondary rated CT. Okay, so our CT only have a nominal secondary current of 1 amp. Okay, so we could be having 1000 amp of current passing on the primary, but the secondary will only show a 1 amp. Okay, but now we need to determine the VA rating of the CT. They are not telling us what the VA rating. They're only telling us that we have a 10 VA relay that will be connected on the CT secondary, and we also have a loop resistance of 2 ohm with a 1 amp current that's flowing through. So how are we going to determine the rating of our current transformer right here? Now we need to ignore the CT secondary windings resistance. Now the first thing to do in this type of problem statement, you need to lay out your circuit, because the circuit is actually going to tell you what you have and see if you can have some form of equations or voltage, Kirchhoff voltage or current law to lay out. And also you need to establish what you have and what you don't have. So right now here we got the relays, the S of the relay, which is 10 VA. Okay, and we got the loop resistance, which is 2 ohm, so that's the impedance, and our nominal current is 1 amp. So we need to find the S base or the S burden of our CT. Okay, then you draw your schematic. Now your schematic is going to look something like this. You have a CT and consider this one here as the bus bar with a current flowing through. The current could be a 1 amp current, or the current could be a 1000 amp or more, but you know that you only have a 1 amp of current that is flowing through the secondary right there. Now what you're going to do, now you don't know what's a CT rating, but they've given you that there is a 10 VA relay that will be connected and a 2 ohm loop. So in order to determine the total power rating of the CT, you need to add these two power, because there is a 10 VA power and obviously a power that will be wasted on the 2 ohm resistance. Okay, so what you need to do is to run a form of a power loop through here, so that you can determine the power being wasted on the 2 ohm and the power being drawn on the 10 VA relay. That is basically what you need to do. So your power equations is then going to be SB, that's the one of the CT here, must be the S of the relay plus the S of the loop. Okay, but how do you then determine this S of the loop? You know this is power, it's apparent power. What's the formula for power? Power have many formulas. So that's the only unknown we have here, because we know that our S of the relay is equal to 10 VA. That we know. But how we determine this one here? This is very simple. So the power formula says S loop, okay, our power is equal to the Z loop times the IN square. Z loop is the 2 ohm resistance, and the IN square here is our nominal current, the 1 amp current that is flowing through there. Very simple, just like that. And now you know that you can find this slope because you have the impedance and you have the current. And that will basically give you 2 times I1 square, and that gives you 2 VA. Okay, now you can clearly see how much is this CT rated, because you can see it's 2 VA that's dropping there and the 10 VA being drawn by the relay. And that basically means your SB is equal to the S of the relay plus the S of the loop, that is 10 plus 2. So this CT here is 12 VA rated. So the CT is rated at 12 volt ampere. So this is our answer. That is so simple. Thank you guys for watching. Please give this tutorial a thumbs up and don't forget to subscribe to CMTEQ channel for many more tutorial complex like this and other important topics in electrical engineering. Thank you for watching. Cheers.